I let you get on.
Yeah, 'cause you let me put
Yeah, you're right.
That was hard.
You did
I was evaluating. How did you do?
Yeah.
Quiz.
All right, guys. So before I get to section 2.6, are there any lingering questions left over? Any of the other sections in 2? Any homework questions? Yeah. Very cool. 94. 2.2. Oh yeah. This is actually one of the most evil things. I especially hated it in my math classes when a teacher would give us a proof, and we'd all be reading through it, and we're like, okay. And after we got to the end, he'd say, "There's a mistake in there. Find it." We're like, "Shit, we agree with that." So this is a very basic example of that kind of thing. They gave you something here that somebody did, and you're correcting it for them. You're kind of being the teacher for something. Did they make a mistake? Did this person make a mistake or not?
Yeah.
Yes. And what do you think the mistake is?
Negative. Should be negative.
Yeah, the answer should be negative. Why do you think they made this mistake possible? Because what rule is pounded in the heads, and you got to be careful about the operation. 2 negatives make a positive. That's only when you multiply or divide, right? When I add, I'm adding debt to debt. I got to end up with debt. We all know that all too well. So when you do this, you should come out with negative. Because 15 and 17 is 32. That's cool. But it should be negative, because they're both negative. It should still be negative at the end. You guys cool with that? That kind of question, though, gets hard when you start looking at something somebody's done. You're like, everything looks good. And then I say, no, something's wrong. And you go, wait a minute, I thought everything was fine. Crap. All right, good. Any other questions from? Yeah.
Can you do 27 from section 2.5?
Which one was that?
This was, what was that one again?
27.
No.
94.
94.
Okay.
94 and 2.2. Nice. So 27, this is section 2.5. And I had it in my head a second ago. 4 minus. Now this should involve some side work, right? I mean, what order operations? What do they tell me I have to do first? Yeah, parentheses. There's nothing to do in here, so I got to now do that exponent. Now the biggest mistake I see is that somebody takes that minus and cancels it with that minus. What operation would that be if I cancel those 2 out? What operation would that be?
Multiplication.
Multiply. And let this sink in. That would be multiplying, and I cannot multiply before I've done exponents. So that's the quick reason why those 2 negatives cannot cancel. Because I don't even know what I'm subtracting from 4 yet. I haven't done this yet. How can I do anything with it yet? All right, good. So the side work would be, what the hell is that? Negative, all of them negative. So there'd be negative 3, negative 3. That's basically what that 4 power means. Power always tells you how many of these things you have multiplied. So what's negative 3 times negative 3? And this negative 3 times negative 3? Is that cool? And then 9 times 9? 81. So now in place of this, I could put 81. Guys?
It'd be positive, wouldn't it?
It is positive. That 81 is positive. But that minus sign came down. You guys with it? This piece is 81, and then you write everything else that's there, because you haven't done anything with the 4 or the minus yet. So all that just comes from the rise. Cool. Good point.
If it was to the third power, then it would be negative in parentheses. 81 would be in parentheses with the negative.
Well, it would be 27, but you're right, it would be a negative, it would still be a negative,
Yeah,
because then there would have been 3 negatives, they would have all canceled then.
but it'd be in parentheses though, right? So
Exactly.
4
To
minus
just
negative
make the
27.
minus and negative, yeah. I'll do that problem next, the one you were talking about. I'll show you the slight modification I can make to this. Now, now how do I do 4 minus 81?
81 minus 4.
I love it. They're different signs. You subtract. What's 81 minus 4? 77. And what's bigger?
Negative.
The negative number, so it's negative 77. All right. I got $4 and I owe you 81. Oh crap! I gotta find some lawns to mow or something. All right. Okay. Now let me modify that a little bit. What if it would have been this? What if this would have been the problem? This is alternate universe number 27. So what if they would have put that? So I still, the same idea applies. I still have to do this piece first.
It'd be a negative 27 because it's an odd exponent.
Yeah, this is negative 3. So now negative 3 times negative 3? 9. Times negative 3? Negative 27. And so in place of this, so the 4 is still there. That minus sign is still there. So this is now negative 27. So I replace this with what it is. And that's huge. I can't make that point enough. Especially when we get into equations. The people that die on equations are normally the ones that don't bring everything with yourself. Right? You don't bring it all. You try to put it at the end together. It's like, whoa. The 4 comes, the minus comes, replace what you just did. Now look at it like it's a new problem. Forget that. Who cares about that? You already did that. Now how do I do 4 minus negative 27?
You can
I
cancel
like
out the
it.
negatives.
The 2 negatives cancel, become a plus. 4 plus 27. I like it. Cool. How we doing? So the big difference there was this 4th power killed that negative. So there was no negative left to kill that negative. You with me? That's why I stayed a minus there. This 3rd power does not kill that negative. There's still 1 negative left alive. There's a negative, cancel that negative and make it a plus. That's the difference between those two problems. All right. Yes?
Say you had a negative on the left side of parentheses with no 4. Like get rid of that 4 and then have the same problem.
All right, wait a minute.
Would you just carry the negative down?
Yes. Well, let's look at it. So you're talking about like this to the
Square.
square? Okay.
Yeah.
Yeah, exactly. Because what do you have to do? Can you multiply or do you have to do the exponent?
Exponent.
So the negative's there. What's negative 3 squared?
9.
Yeah, we've done it several times, right? So in place of this, I put 9. You're done. And this is where students sometimes go, Jeff, man, you said when you square a number, you always get a positive. You do. That is 9. And there's a negative sign in front of it. I mean, what can you do? You can't do anything with that guy. He's just hanging out. He's like, I'm waiting until you're done. You're 9. That's nice. And I put myself on. There you go. Came out kind of weird this time. I mean, is that, you guys with me? You've seen the same kind of thing like when they have this. An absolute value has to come out positive. So when I tell a student the answer is this, they're looking at me like, I'm going to hurt you. Because you just said, and that's why I hate math, because math always changes the rules, and it's just evil, and every day you decide how to change the rules, and you're evil. Like, I am evil, but not because of that. That is
11.
11. And the negative is still there. Nothing's happening to him. Why would he go anywhere? Cool. All right, I like that. Any other questions from the homework?
Can you do number 81 on that same section? Super
Oh, yeah. Okay. How do you always find the average of a set of numbers? How do you always do it?
Add them up, divide by the number of numbers.
Yep. You add and then you divide and come
I like
back down.
So the rule doesn't say a damn thing about negatives, positives. It just says you add them up. So it's just the rules of addition. So if I add up a bunch of negative numbers, I'm going to have at the end
Negative
a
number.
negative number. Right? So I just add these guys up. I know the answer is going to be negative, so I can just kind of focus on adding these guys. Because they're all negative. Are you guys cool with that? All negative. I know the answer is going to be negative. I can just focus on adding them then. So when I add these, what do I get? And here's how I would add these. 17 and 13 is 30. And 20 is 50. And 26 is 76. Right? So then these add to be negative 76. And then I divide it by 4.
What if you had a positive in there?
Then you have to be careful, because then you'd have to kind of step through it, because that 1 you have to subtract. Right? I like it. But in this case, they were all negative. I can just add them all and put the sign back on. Negative 70. What's 80 divided by 4? Let me see here. What's 80 divided by 4? 20. 76 is 1 4 less, so it's not 24s, it's 19. So when you have a number that's really close to an easy number to divide, do that and then just take off the appropriate number of those things. I don't know if you guys are working on that. Or how else can you do it? You can just do it like this. Or you can just, put in the calculator, because I would never, but. So this will be negative 19, right? Because that negative is still. Nothing cancel with that negative. It's still negative. Can anybody tell me, real quick, if I had this list of numbers here, and the question was to find the average, if I get this as my average, why does that make any sense?
Because it's a higher number than
It's higher than all of them. The average should be kind of in the middle of all the numbers. So, in that way, does negative 19 make sense here? Yeah, it's in the middle. It's above those. It's below. It's in the middle of all of them, so that negative 19 makes sense here. It's kind of a nice way to make sure, at least, that it makes sense. If you get negative 76 and you forget to divide, that doesn't make a damn bit of sense. It's way bigger than all of them. How could that be the average? Right? All right. Any other questions from what we get? Number 13? 2-4? Oh, they love those deep sea divers. A deep sea diver must move up or down in short steps in order to keep from getting a physical condition called a bend. Anybody scuba dive? Hopefully you never had that, because that is heinous. Suppose a diver moves down from the surface in 5 steps of 20 feet each. So starting at the surface, every time, 3, 4, 5. So 5 times, and every time they do it, they're going to go down how much? They're going to do 5 times, and each time they do it, they go down 20 feet. So how would I represent this piece as a signed number?
Negative 20.
Negative 20. So each one of them, negative 20. Represent the total movement as a product of signed numbers. And then do it. So, I mean, this is the basic definition of multiplication here, right? How many negative 20s do I have?
5.
So how can I write that? as a
20
math?
to the 5th power.
Careful.
I mean, negative 20 to the 5th.
So negative 20
Oh, wait, what am I doing?
times 5, yes. 5 there, you put 5 there, doesn't matter. So I have 5 of these. In this case, I would have to add them to see the total depth. You got your dude like going
I know, he's
Mariana's Trench, like all the way to the bottom.
He already popped.
He's going to reach those.
he crushed.
Those aliens from the abyss are hopefully going to save him. That's one of my favorites. So what do you get when you do that? 5 times negative 20? Negative 100. Is that cool? You can always check yourself, because you would just do negative 20, negative 40, negative 60, negative 80, negative 100. There you go. There's 5 negative 20s. I like it. All right. I know when we see a problem where there's a lot of words involved, we all kind of cringe a little bit, because word problems are coming. but they're not here yet.
Those
This
seem to
is
be
just
the only ones that I grasp, because I have something to like.
something
okay,
physical.
Yes.
I like it. That's the way you should look at it. Because I keep trying to make, this kind of problem. I owe somebody $5. You try to instill some physical connection with them, right? Here, this is you can see the dude died. You can see him going down, so it's going to be negative. I like that. Good. But most of it, we don't even read the problem yet. We're like, oh crap, there's a bunch of words. Shit, is this going to be one of those train problems? Train leaves Wyoming, going south at 40 miles an hour. No, not yet. Okay. So, let's get into the last section in chapter 2.
Yay.
So I noticed that a lot of you guys know how to solve some basic equations already. That's awesome. But you got to be careful. There were some questions earlier in the chapter that they asked you, is this a solution to this? They want you to plug that number in and check. Don't solve the equation yet. Now the rest of us are all like, I don't know how to freaking solve equations. So here's the basic idea. Let me try it this way. What's the idea behind x in general?
Number we don't know.
I love it. It's a number that we don't know yet. I am allowed to assign it almost anything I want to, depending on the problem. So I just have x sitting there. What number do you want to make x equal? 2. I love it. So say x is 2. Just go with me. I'm going to show you a little insight into how teachers create problems. We start with the answer, and then we build off of that. And we make you do everything backwards. That's the idea of algebra. So if x is 2, what's x plus 4? If x is 2, x plus 4 must be 6. Is that cool? Because whatever I do to one side, I have to do the other side, or else it's not the same. It's not the same balance. I was thinking about Indiana Jones with that gold statue, and he puts the sand in. Of course, he didn't balance his equation correctly because the damn ball came down. But whatever you do to one side, I got to do the other side so everything stays balanced with it. But doesn't this just make sense fundamentally? If something is 2 and I add 4 to it, that something better be 6. I mean, that's all there is to it. So the whole point of this chapter is, this section, they start you there, and you just have to work backwards to see what the hell x was. They don't tell you what they started with. They say, well, this is where we got. Can you remind me what the hell I started with? Because I forgot. So here's how you do this. And this is, and I completely understand that these equations are pretty basic right now. If I just ask you, what do you add 7 to get 10?
3.
Okay. So what that would look like algebraically is, what do I add 7 to get 10? I do not want to see that, and yay! When we get to more difficult equations, I want to make sure that you've got the right ideas how to set it up. So you don't mess yourself up later when you can't just look at an equation and go, oh, it's 7, or whatever. The steps you do are you show yourself what the hell you're doing. Subtract 7. And why? Now, if I just tell you in English, I just say, what do you add 7 to get 10? You guys in your head, you did 10 minus 7. Then work back to see what the hell it would have had to been, right? So that's what my whole goal in solving an equation is to get x by itself. Because an x equals something, and then I know what the answer is. So I'm trying to strip all the stuff off of the x. If I got a plus 7 on it, I want to subtract 7. I want to do the opposite so I get the x by itself. Whatever I do to one side, I better do the other one, or else everything's off balance,
So
right?
what if x not minus 7? It would be positive 7?
Oh, if it was a minus 7?
Yeah.
Yeah, we'll do that next.
So okay.
Yeah, we'll do that next. So on this side I get x, right, the x is still there, the 7's go away, equal sign, 10 minus 7, 3. So on one level right now you're going, that didn't help me out. I knew the damn answer was 3. Right? Why the hell do I need all that crap? You need all that crap for when we get to 2x minus 7 times x plus 4 equals 3x minus 2 plus 7. Right, can you just look at that and tell me? Hell no. So we got to build up the little steps so I can do the step, do the step, do the step to get to the answer. That is way in our future, by the way. But I just want to make sure you guys understand that there's nobody out there that's just going to give me 3 and then argue, well, it's 3. I can just see it's 3, Jeff, leave me alone. I have got to make sure you're able to set it up correctly so that you're able to do this later. So let's do like you said. What if it was x minus 7 equals 10? Whatever you have to do to get the x by itself is what you do. Right now I'm subtracting 7. How do I kill that minus 7? How do I get the x by itself? Add 7. Right? So if I mistakenly subtracted 7, do those cancel? No, the x won't be by itself. Right? That x wants to be by itself. Very antisocial. So if I add 7, those do cancel. What do I have left on that side? X equals 17. I love it. There you go. And is it true? 17 minus 7 is 10. You can always check your work, thank God. You can always check it. Just take x minus 7 equals 10. Plug in what you think the answer is. And check. It works. Thank God. Because that's the biggest mistake I see with these, is if I have, if I have x plus 2 equals 8, I always have somebody do this. What mistake was made? Yeah, would this be x here? No, it would be x plus 4. You've made it worse. Right? There's more shit with the x now. I don't want that. I want less. I want that totally by itself. So how do I get the x by itself? Minus 2. X, that cancels, equals 6. I love it. All right. So let me throw some more operations in here. The biggest mistake I see on this problem, before anybody gives me a suggestion, the biggest mistake I see on this, that is a mistake. Mistake. Danger, Will Robinson. Because what you'll see me write, and even though I'm saying this right now, a lot of us are going to do this because it's very human. We see the 3. We don't want the 3. We want the x by itself. Let's subtract the 3. And your brain says, yay. And it's a very human thing to do. But what's the operation there?
Multiplication.
Multiplication. Can subtraction cancel multiplication? Hell no. So how do I do this problem?
Divide.
Yeah, each side you divide by 3. You divide by the thing you don't want, because the thing you don't want is currently multiplying. So I want to kill it. I do the opposite operation. Whatever you do to one side, I immediately do the other side. The 3's cancel. So you get x like I want. 36 divided by 3, 12. And if I want to check it, 3x is 36. I think x is 12. So I put a 12 in. Is that true? Of course it's true. Yeah.
What if you're dividing x over 3?
I love it. Get out of my head. That's where I'm going next. So like the gentleman said, what if you're taking x divided by 3? What the hell?
Then you multiply 3.
Yeah, exactly. So if I had x over 3 equals 11.
Guess what?
So you say to yourself, I want my x by itself. Why is it not by itself? Stupid 3. What's the stupid 3 doing? Dividing. What am I going to do? Multiplying. I want to do the opposite to kill it so I can get the x by itself. My mathematics is very violent, if you haven't noticed. I have things dying and killing. So both sides, to kill that 3, I have to, let me write it again down here so I can keep it separate. Multiply. And if you want to, you can put 3 over 1, because it's the same thing as 3. It's a little ahead of us. It's fractions, but still. I better do the same thing to this side. Multiply by 3. What happens on this side? The 3's cancel, right? So x equals 33. Check. X over 3, I think x is 33, so let me plug it in. 33 over 3, is that 11? Yes, I'm right. Sweet. Okay, how are we feeling so far? Feeling all right?
So why did we divide in the left side and we multiply on the right side? Yeah.
We multiplied both sides. Because what did I bring in? What did I bring in that was not there? I multiplied this side by 3, and I multiplied that side by 3.
It's a 3 over 1 you have that's confusing.
Yeah.
I just put it there in case you needed to. I could put, anywhere I have a 3 sitting, Ken, I just put it over 1. I could put over 1. I could put a 1 under any damn thing I want to. You guys with me? I didn't know if that would help, because that's a fraction. I didn't know if that would help to make that one look like a fraction. If it doesn't, don't do it. No need. But I'm still multiplying by 3. And I better do the same exact thing to that side, multiply by 3. The most common mistake I see on this kind of problem
So it's 3 times x.
is I have something like this. I'll have an x over 3 equals 12. And somebody does this. And they get x is 4. What was the mistake there? This side they multiply by 3, this side they divide it by 3. So that's math. I see that often, especially when that number is divisible by 3. Your brain just says, oh, 3 goes in there, let's do it. And you say, no, brain. Don't be stupid, brain. Multiply, because I multiply that side, I better do the same thing to this side. So the 3's cancel, and I get 36. Okay, so let me add one more level on top of this. Why do math people got to do that? Now, and real quick, let me say this. As we're getting into these equations, it's really easy as a student to just think, this is nice for math people to sit around and play with this stuff, but why the hell do I have to do this shit? Because where do equations come from in real life? It isn't some guy starting with x equals 2 and adding stuff onto it and just throwing it to you at your desk and going, do that work. Yeah. It's real life. I make an equation to model airplane taking off and coming out. And then I try to increase the efficiency of the airplane. And, you know, you can have equations dealing with the wind that comes in and figuring out how long do I have to wait for another airplane to come up. Did you guys ever hear about that? They were having certain airplanes go too fast behind another one, and the squall, the thing coming off the first airplane pushed the other airplane down as that downburst, and they were having the airplanes crashing or having to land again. So they had to do an equation to figure out, okay, what would be a good distance, and how could I model that turbulence of the wind? And that would be a really ugly equation, but it's the same idea. Your equation comes from whatever the hell you're working with, and then you have to solve it so you figure out what the hell to do. So you have people working at, my friend Sean he used to work at Dell. Now he works for Select Comfort, but he's making crazy amounts of money. But what he does is he tells them what to set their prices at based on market realities, like the demand. What price can I set it at to make the highest profit? If your price is too high, none of people want to buy it. If your price is too low, everybody wants it, but you're not making money. So his job is to kind of keep track of all the different stuff, change his equations and solve them and tell them, set the price of this, set the price of that. That's one piece of the job. You guys kind of with me? So equations are not just things that I put, so a letter and another number, and let me put another letter over a number. No. I mean, that's what I'm doing here to learn it, but in the real world, they just come at you from whatever you're dealing with. So what if I have, here's my next level. I forget what number I want. Let's just start.
Just subtract 30 odds both
The key here is to remember our goal. Our goal is to get x by itself equals a number. So the main problem here is I got some x's that ain't all on the same side. I need them on the same side, don't I? I have to have x equals number. Right now I got some x's equals some x. Oh, that's not good. I got to get my x's together, right? So the clue, the thing, if you want to move something from one side to the other, I want to get my x's together. I want them to cancel on this side. I don't want the x's on this side, do I? So how do I kill those 3 x's there? How do I make that 3x go away?
By subtracting.
Subtract it. I love it. Because right now it's positive 3x plus 5. I subtract 3x to make that go away. I'm trying to collect all my x's on one side. You guys kind of with me? I know a few of you guys are way ahead of me. Just hang out. All right? Make sure everybody's on the same page. So on this side, exactly what happens is what I want to have happen. I want no x's on that side. I just want a number on that side. And the number I have on that side is 5, because this piece went away. Now here's the trick. What's 4 x's minus 3 x's? 1x. I love it. So then I'm there. I'm done. Yes, sir.
What if it's 5x equals 3x plus 5 and you get 2x?
That's actually the next chapter.
So basically, right now, whatever number's on the side, that will be the answer.
Exactly. Because this is saying,
Because it's only
and
one
here's
x.
really the whole story. What math is trying to tell you is when this is true, this is true. There's no other x. Math is saying there's no other x besides 5. There's no other value besides 5 that will make this statement true. So if you try to throw a 6 in there, let's try it. What should I get? If I try to throw a 6 in here, I'll get 4 times 6 equals 3 times 6 plus 5. I'll get 24 equals 18 plus 5.
24 equals 23.
24 equals 23? No. And I already know 6 won't work because only 5 will work. So if I put a 5 in there, 4 times 5 equals 3 times 5 plus 5. 20 equals 15 plus 5. Yay. You good? You guys with me? See? When will it be online? Hopefully very soon. In fact, if I remember, I should be uploading it this afternoon when I get back home. I used to download it to my computer and then upload it from there. And now I figured out I can just do it off my phone directly. I know, a lot of you guys already need to figure the damn thing out. And the beautiful thing about that is if I leave my wireless and I go somewhere else, it waits. And I didn't know it would do that. And I'm like, I got a cap of a certain amount of data I can do. I don't want to do it all that crap. But it waits until I connect to another. Anyway, do you guys really need to know that? Short answer, I'll get it up this afternoon. All right, Jeff, just answer. Okay. So, here's what I want you guys to do for the rest of the time. Is to work on this together. It's page 44 in your little blue book. So hopefully a lot of you guys have this today. So I didn't bring that many copies. You want? Thank you. Anybody else need a copy here? Need a copy of it? 44. That's for that one. So these two as it comes. And then addition, subtraction as it comes. Definitely parentheses, definitely exponents. And then multiplication, division as it comes. Addition, subtraction as it comes. Anybody else need a copy of that page? Yeah.
What page?
44.